Tree work is one of the most dangerous professions in the world. Every experienced arborist knows that. But here is the critical truth that separates professional crews from accident reports. Most serious incidents in arboriculture are preventable. They happen when hazards are overlooked, when communication breaks down, or when safety systems are ignored. For Board Certified Master Arborists, safety management is not just about wearing gear. It is about building systems that prevent injuries before they happen. In this podcast, we are going to walk through the essential safety concepts used in modern arboriculture operations. We will explore personal protective equipment, climbing safety systems, electrical hazards, job site organization, and emergency preparedness. These are concepts that appear regularly on the BCMA exam, but more importantly, they are concepts that keep arborists alive. In this podcast, we will explore how professional arborists manage safety in real working environments. We will discuss how crews conduct a hazard assessment, how they organize a safe work zone, and how a job briefing helps crews identify risks before work begins. We will examine the role of personal protective equipment, often abbreviated as PPE, including leg protection, safety eyeglasses, climbing helmets, and fall protection systems. We will also look at electrical hazards, including energized conductor risks, and the responsibilities of a qualified line clearance arborist. Finally, we will cover rescue planning, including aerial rescue procedures, rescue kits, and the risks associated with suspension trauma. All of these concepts form the backbone of professional safety management. Let's begin with the foundation of all safety programs. Safety itself is the condition of being protected from hazards that could cause injury or death. But safety does not happen by accident. It requires a strong safety culture within an organization. Safety culture refers to the shared attitudes, beliefs, and behaviors related to safety. In a strong safety culture, everyone takes responsibility for identifying hazards and preventing incidents. Closely related is the idea of safety climate. Safety climate reflects how employees perceive the organization's commitment to safety at a particular moment. If workers believe management truly prioritizes safety, the safety climate is strong. Before any work begins, arborists perform a hazard assessment. A hazard is anything that has the potential to cause harm. Hazards may include unstable trees, electrical conductors, chainsaw use, falling limbs, or environmental conditions. A hazard assessment identifies these risks and determines how to control them. This is where the job briefing comes in. A job briefing is a pre-work meeting where the crew discusses the hazards present, the work plan, communication methods, and emergency response procedures. This is also where crews define the drop zone and the larger work zone around the tree. The drop zone is the area where branches or debris may fall. The work zone includes the broader space where workers, equipment, and the public may be affected by the operation. Professional crews establish barriers, signage, or spotters to control these zones. Now let's talk about personal protective equipment. Personal protective equipment, or PPE, includes the gear arborists wear to reduce injury risk. For head protection, arborists may wear either a hard hat or a climbing helmet. The climbing helmet is specifically designed for vertical work and often provides chin straps and impact protection from multiple directions. Eye protection typically comes in the form of safety eyeglasses, also called safety glasses. When operating chainsaws, leg protection becomes critical. Arborists use chainsaw pants or chaps to protect against accidental chain contact. These garments contain fibers that quickly clog the saw chain if contact occurs. This dramatically reduces injury severity. For climbing arborists, fall protection systems are essential. A fall arrest harness is designed to stop a fall and distribute forces across the body. In contrast, most arborists use work positioning systems rather than fall arrest during climbing operations. These systems allow controlled movement within the tree. The climber's access line is the primary rope used to enter and move through the tree canopy. The climber may also use a steel core lanyard or other positioning lanyard when operating a chainsaw in the tree. Steel core lanyards resist accidental cutting from saw contact. Another important tool is the chainsaw lanyard, which secures the saw to the climber and prevents it from falling. Field-based arborist example. Imagine you are inspecting a large oak scheduled for removal in a residential neighborhood. Before anyone leaves the ground, the crew performs a hazard assessment. They identify dead limbs, nearby electrical conductors, pedestrian traffic, and a narrow driveway where equipment will operate. During the job briefing, the crew defines the drop zone beneath the canopy and establishes the larger work zone that keeps homeowners and bystanders clear. Communication methods are discussed using a command and response system. In this system, instructions are repeated back to confirm they were heard correctly. For example, the climber might call out rope clear, and the ground worker responds, rope clear confirmed. This simple process prevents many accidents. Now the climber installs the access line and prepares to ascend. They are wearing chainsaw pants, safety eyeglasses, a climbing helmet, and their climbing harness. Their chainsaw is attached with a chainsaw lanyard. These systems work together to reduce risk throughout the operation. Diagnostic thinking for arborists. One area where arborists must exercise extreme caution involves electrical hazards. Trees often grow near energized conductors. These are electrical wires carrying current. Direct contact with an energized conductor can result in electrocution. Understanding electrical systems is critical. Electricity flows through conductors. A conductor is any material that allows electrical current to move easily. Electrical distribution systems involve different phases of electricity. These phases can create several types of electrical exposure. Phase-to-ground contact occurs when electricity flows from a phase wire to the ground. Phase-to-neutral contact occurs between a phase wire and the neutral conductor. Phase-to-phase contact occurs between two energized phase wires. Each of these conditions presents serious risk. Professional arborists must also respect the minimum approach distance, often abbreviated MAD. The minimum approach distance defines how close workers can safely get to energized conductors. Only a qualified line clearance arborist is allowed to work within those distances. These professionals receive specialized training to manage electrical hazards safely. Equipment used near electrical systems must often be dielectric or non-conductive. Dielectric materials resist electrical current flow. Tools made from fiberglass are common examples of non-conductive equipment. Exam insight moment. This distinction often appears on certification exams. You may be asked to identify the difference between conductive and non-conductive equipment, or to understand why only qualified line clearance arborists can work near energized conductors. Field-based arborist example. Now imagine a tree crew working near overhead power lines. A mobile elevating work platform, or MEWP, is used to reach the canopy safely. The MEWP must be stabilized using outriggers before elevation begins. These extend from the machine and create a wider base for stability. The operator must maintain proper distance from energized conductors. If electrical hazards are present, only a qualified line clearance arborist may perform the work. Chainsaw safety concepts. Let's turn briefly to chainsaw hazards. One of the most dangerous events during chainsaw operation is kickback. Kickback occurs when the saw's kickback quadrant contacts wood or another surface unexpectedly. The kickback quadrant is the upper tip of the guide bar. If that region contacts wood, the saw can rapidly rotate toward the operator. Proper cutting techniques reduce this risk. Arborists often begin cuts at the starting corner of a notch when making directional cuts. Proper body positioning and escape planning are essential. Every arborist should establish an escape route before completing a felling cut. Professional arborists also plan for emergencies. Every climbing crew should have a rescue kit readily available. This kit contains equipment used during an aerial rescue. Aerial rescue refers to retrieving an injured climber from the tree canopy. Time is critical in these situations. One specific medical risk is suspension trauma. Suspension trauma occurs when a climber remains motionless in a harness for extended periods, reducing blood circulation and potentially causing unconsciousness. Fast rescue response is essential to prevent this condition. Crews must also maintain training in first aid and emergency response procedures. Certification exams often test your understanding of emergency preparedness. Questions may focus on aerial rescue readiness, first aid capabilities, and the importance of having a rescue kit immediately available. Another concept that appears in safety standards involves equipment strength. Every rope, lanyard, or climbing component has a breaking strength, which is the amount of force required to cause failure. Minimum breaking strength defines the lowest strength rating permitted for safety equipment. The tensile strength of a material describes its resistance to pulling forces. Because no system is perfect, arborists use a safety factor when designing equipment. The safety factor ensures the equipment can withstand forces far beyond normal working loads. Over time, repeated loading can weaken materials through cycles to failure. Each time a rope or component experiences stress, microscopic damage may occur. Eventually, enough cycles lead to failure. Regular inspection helps prevent these hidden failures. In arboriculture safety standards, wording also matters. The word shall indicates a mandatory requirement. The word should indicates a recommended practice. Understanding this distinction is important when interpreting safety standards. Concept reinforcement. Let's bring these ideas together. Professional arboriculture safety depends on several interconnected systems. Hazard assessments and job briefings help crews identify risks before work begins. Clear communication systems like command and response prevent misunderstandings. Personal protective equipment protects workers from injury. Climbing systems rely on strong materials with appropriate safety factors. Electrical hazards require strict adherence to minimum approach distance and specialized training for qualified line clearance arborists. Emergency preparedness ensures crews can respond quickly to accidents through aerial rescue and first aid. Together, these systems create a strong safety culture and a positive safety climate. Chapter Wrap-Up. Safety management is not a single tool or piece of equipment. It is a system of awareness, preparation, communication, and discipline. Board Certified Master Arborists are expected to lead these systems on job sites. They set the example for safe operations and ensure crews follow professional standards. In the next chapter, we'll explore tree preservation during construction and development, and how arborists protect root systems and soil conditions when trees and construction must coexist. You've been listening to the Arborist-podcast. Our goal is to grow our collective knowledge, one domain at a time, and we're glad you're here for it. If you enjoyed the show, please like, share, and subscribe to help us keep this momentum. Until next time, let's keep growing this community together. We'll see you in the next one.